Okay, Bismillahirrahmanirrahim. Assalamualaikum and good morning to all students. Boleh dengar suara saya jelas?
Jelas, sir.
Okay, thank you. Alright, so sebelum saya mula, saya nak highlight sikit berkenaan konten di dalam kalam. Okay, so basically let's look at the content of the course. Okay, so basically we have covered course outcomes number 1 and course outcomes number 2. This is based on the chapters lah. So kita dah finish chapter 1, kita dah finish chapter 2. So now we are discussing about chapter number 3, okay, which is solving dynamics quantities in the kinetics of particles utilizing work energy concept. Okay, so kita tengah sedang belajar tentang work and energy. Okay, basically like what I have shown in the course structure ni lah, kita basically berada pada chapter yang ketiga. Okay, now I would like to talk about the assessment. So as we have discussed in the previous class, okay, so I think most of you have agreed that we are going to repeat quiz 1 and quiz 2. So for now, apa yang kita telah jalankan ialah quiz 1, quiz 2 dan juga test 1. Okay, so in total 6%, 6%, 15%, so 27% lah altogether assessment yang telah kita jalankan. Okay, so I am planning to do the quizzes lah, repeat quiz 1, quiz 2, quiz 3 pun kita belum buat, which will cover chapter number 2, quiz 3, and also quiz 4, which will cover chapter yang sedang kita discuss sekarang ni, which is chapter 3. So I am planning to do all the quizzes, quiz 1, quiz 2, quiz 3, quiz 4 pada hari Isnin, Monday minggu depan. Okay, so we will do this face to face in the Dewan Kuliah 300 in FTKMA. Do you have any problem with that date? Ada tak yang siapa-siapa yang tak boleh hadir for the quiz? Ada yang ada problem untuk hadir pada Isnin next week, Monday next week for the quiz. So basically setiap quiz I will give you 15 minutes to answer. So quiz 1, quiz 15 minit, quiz 2 15 minit, quiz 3 15 minit, and quiz 4 15 minit. So altogether 1 hour lah. So we have 2 hours class on Monday next week, 10 sampai 12. So we will start with the lecture first, okay, and then we will finish with the quiz. Okay, so kalau tak ada problem, that will be the date for the quizzes lah. Kita akan repeat quiz 1 and quiz 2, and then there will also be quiz number 3 and quiz number 4. Okay, so 4 quiz lah daripada 3 chapter. Quiz 1, quiz 2 ni datang daripada chapter 1, quiz 3 daripada chapter 2, and quiz 4 dari chapter 3. Okay, so please do revision on these chapters, because as you can see the percentage for the quizzes are very big. Okay, so 6% for every quiz. Kalau kita jalankan 4 quiz ini, bermaksud 24% of your final mark comes from this quiz yang kita akan buat pada hari Monday. Okay, so I hope you can do your revision, and I will see you on Monday for the class. In the beginning, we will do the class first, and then we'll do the quiz. Okay, so going back to the lecture that we have covered so far, I have uploaded the videos for lecture week 9. Okay, this is week 9 yang kita telah buat secara online through Microsoft Teams. Okay, this is the video, and this is another video from last semester, so you can watch both videos. Perhaps it will increase your understanding lah on the topic that we are currently discussing. Okay, and then This is week number 10. Basically, minggu lepas week 10 2 hari. Minggu ni pun masih lagi week 10. Okay, so this is what we are going to cover today. So I have uploaded also the video from previous semester. So you can watch these two videos, and the recorded videos from today I will also include in week 10. Okay, so by next week we will finish with chapter 3 lah. So today I will cover the principle of work and energy as well as power and efficiency. And next week we will cover the conservation of energy, and then we will finish with chapter 3. And on Wednesday next week, Monday kita akan finish dengan chapter 3. Kita akan finish chapter 3 and also do the quizzes. On Wednesday we will go into the last chapter lah, chapter 4. Okay, do you have any question with the arrangement of the class for next week? Okay, if there's no question, then I would like to continue with the lecture, what we are going to cover today. Right. Okay, so can you see my screen? The principle of work and energy. Boleh nampak screen saya?
Boleh, sir.
Boleh, sir.
Okay, all right. So now, last week or last 2 weeks, the previous class, we have discussed about the kinetic energy and also the work done. Okay, so kita dah belajar tentang kinetic energy, which is using the symbol T. T is equal to 1/2 times the mass times the velocity square. Okay, 1/2 mv square. That is the kinetic energy. And then we have learned about work done. Okay, work done ada pelbagai jenis. So basically, work will be done if the object is moving in the same direction as the force punya direction. So force punya direction is in the same direction as the distance travel by the object. So akan ada force yang melakukan kerja, akan ada force yang tidak melakukan kerja. So we have covered all this last week. Okay, ada work done by force. Kita dah belajar tentang work done by weight. Okay, minus W times delta Y. We have learned about work done by spring, and also that's it lah. Work done by force, work done by weight, and also work done by spring. Okay, so now we will combine the kinetic energy that we have learned and also the work done to become the principle of work and energy, so that we can use this principle to solve related problems. Okay, so the outcomes of today's lesson is you should be able to understand, derive and understand the principle of work and energy, solve problems related to the principle of work and energy, and also solving problems involving a system of particle. Maksudnya ada more than one object. So we will look at this later. Okay, I hope you have watched the videos that I have shared, and also look at the slides, because I will go through this quickly, and then I will cover a few examples. Okay, so if we look at this particle moving from position 1 to position 2, particle ni yang warna biru ni, particle ataupun objek lah, is moving from position 1 to position number 2. So since it is moving in a curvilinear path, kita boleh pecahkan dia kepada components in tangential axis. This is tangential axis T. So akan ada force in tangential axis, dan kita akan ada normal axis pointing to the center of rotation, center of the circle ni lah, center of the arc of the path. Okay, pointing to the center. this is the normal axis, so we are going to have forces in normal axis as well. So ini dia punya resultant force lah, force yang force vector is in this direction. So force ini kita boleh pecahkan kepada tangential axis dan juga normal axis. Okay, but because the particle is moving to the right in tangential axis, so we know that normal forces in normal axis tidak menjalankan apa-apa kerja because there is no displacement in normal axis. Displacement hanya berlaku pada tangential axis. Okay, displacement maksud dia objek ini bergerak pada tangential axis. Objek ini tidak bergerak atas bawah pada normal axis. So tidak ada kerja yang dilakukan oleh forces in normal axis. Okay, so force in tangential axis kita boleh tulis sebagai Ft sama dengan MAT. Okay, M kali AT. AT ini macam mana untuk kita dapatkan? Kita boleh gunakan basic kinematic equation yang kita belajar pada chapter 1 dulu. A ds sama dengan V dv. So kalau kita bawa ds ni ke sini, dia akan jadi basic kinematic equation yang kita belajar pada chapter 1. So we can rearrange the basic kinematic equation to get AT is equal to V dv V times dv over ds. Okay, V times dv over ds. So ds ni kita boleh bawa ke sebelah kiri, so it will become A ds sama dengan V dv. Okay, so from here, okay, so if you look at this this equation here, we can combine these two to get Ft ds. Kita rearrange ds ni ke sebelah kiri. Okay, Ft ds is equal to mv dv. Okay, so we can do the integration. Ini saya hanya menunjukkan macam mana equation ini terbit. Nanti you tak perlu derive equation ini dalam test ataupun final exam. What you need to do is just use the equation, tapi saya hanya menunjukkan macam mana equation ini datang. Okay, so in the end, on the right hand side ini mv dv, kita akan dapat v square over 2. So dia akan jadi 1 over 2 mv2 square minus 1 over 2 mv1 square, because the lower limit and upper limit is v1 to v2. Okay, so just focus on this equation here. Okay, so what we have on the left hand side, f kali displacement, ds is the change of displacement. Okay, so f kali displacement ialah work done. So bila kita tengok daripada S1 hingga S2, dia bermaksud work done to move from position 1 ke position 2. So on the left hand side of this equation is basically the work done to move daripada 1 ke 2. Work done kita dah belajar dalam kelas yang lepas lah. Work done by force, work done by weight, work done by spring. On the right hand side, this is basically kinetic energy. 1 over 2 mv square is kinetic energy. Cuma ada dua kinetic energy dekat sini. Kinetic energy pada position kedua, v2 square, dan kinetic energy pada position pertama, v1 square. So apabila kita tulis semula equation ini untuk memudahkan lagi kita faham, kita akan dapat persamaan seperti ini. Okay, T1 plus total U to move from position 1 to position 2 sama dengan T2. Okay, T1 ini basically yang inilah 1 over 2 mv square ni kita bawa dia ke sebelah kiri, so negatif ini akan hilang. Okay, dia akan jadi T1, kinetic energy pada position yang pertama. So ini ialah initial kinetic energy. Kinetic energy yang pertama tambah work done to move from 1 to 2, work done to move from position 1, position 1 ke position 2, is equal to the final kinetic energy. Okay, so ada kinetic energy yang pertama, ada kinetic energy yang kedua, dan ada di tengah-tengahnya ada work done untuk travel daripada position pertama ke position kedua. This equation is what we call the principle of work and energy. So yang tadi semua saya tunjuk derivation tadi, you tak perlu remember, you just perlu tahu macam mana dia datang. Tapi what you need to remember is this. This blue color equation is the one that you have to remember. Okay, T1 plus total work done is equal to T2. Okay, total work done. Ini bukan U1 tolak U2. Please bear in mind or remember this. Ini bukan U1 tolak U2. Ini maksud dia U1 ke 2. Maksud dia total work done untuk move daripada position 1 ke position 2. Okay. So that's all lah. Ini sahaja yang kita nak cover pada hari ini dan kita akan tengok a few examples. Okay. So daripada kelas yang lepas kita telah belajar kinetic energy. Ada dua kinetic energy dalam equation ini dan kita telah belajar work done. So now we are combining kinetic energies and work done to get the principle of work and energy. Okay. Do you have any question? Kalau tak ada soalan, I will proceed to the problem. Okay, let's go to the example problem. Okay, ini soalan yang kita dah buat pada kelas yang lepas. We have calculated the total work done. Kita dah calculate total work done sahaja for this problem. But now we are going to solve the actual problem. Let's read the problem again. The spring is placed between the wall and the 10 kg block. Okay, ada 10 kg block warna biru, ada wall di sebelah kanan dan ada spring di tengah-tengah. The block is subjected to a force of 500 Newton. So ada satu force di-apply kepada block ini 500 Newton tapi bukan straight line force ataupun bukannya pada x-axis tapi dia di-apply pada satu angle. Okay, at an angle. Determine its velocity. Determine velocity block ini apabila S is 0.5. So apabila block ini telah bergerak ke kanan 0.5 meter, what we want to know is what is the velocity of the block. When S equals to 0 pada posisi yang pertama. S equal to 0 ni position yang pertama lah. S equals to 0.5 is the position yang kedua. This is what we are talking about, position 1 and position 2. So position 1 is when S equals to 0, the block is at rest. Okay, so dia kata pada position pertama, block ini at rest, tidak bergerak. And the spring is uncompressed. The contact surface is smooth, jadi tak ada friction. Okay, so kita nak tahu apa velocity apabila block telah bergerak sejauh 0.5 meter. Okay. So kita draw free body diagram, ada mg ke bawah, ada na ke atas and ada 500 Newton forces yang kita boleh resolve into x and y axis. Okay, x axis ialah 4/5 times 500. Saya dah explain minggu lepas macam mana you dapat this. This is trigonometry by using the triangle yang diberi di bawah ini. Okay, and the component of force in y-axis is 500 times 3/5. Okay, so from this we know that mg, na dan juga this component of force are not doing any work because they are the direction of these three forces are in y-axis. Sedangkan blok ini bergerak dalam x-axis. So all these three forces are not doing any work. Yang menjalankan kerja hanyalah this component of force 500 times 4/5 dan juga spring, because spring will be compressed. Okay, so spring akan menjalankan kerja dan juga 500 Newton the component the x component of 500 Newton force will be doing work. Okay, so UF kita dah calculate minggu lepas is 500 times 4/5 times the distance. Okay, ni force dia, component of force, 500 times 4/5, and to calculate the work done we have to multiply with the distance. So distance dia ialah 0.5. Okay, travel 0.5. So we got 200 joule, okay, for UF. And then US, work done by spring, is minus 1/2 times K. K is the spring constant, 500 Newton per meter, given in the question. S2 square minus S1 square. S2 and S1 is the elongation, pemanjangan spring. Okay, so dia kata apabila S equals to 0, the spring is uncompressed. Maksudnya pada position yang pertama, iaitu S1 ini, spring itu tidak ada pemanjangan. Dia berada dalam panjang yang asal, yang original length, uncompressed. So from this statement, we know that S1 ini equals to 0. Okay, S1 equals to 0 because the spring is uncompressed pada position yang pertama. Pada position yang kedua, berapa banyak dia dah decompress is equal to berapa banyak blok itu bergerak lah. So apabila blok bergerak 0.5, maksudnya spring itu decompress sebanyak 0.5 juga lah. Dah blok bergerak ke kanan 0.5, therefore the block will compress the spring sejauh 0.5 meter. Okay, so S2 pun sama dengan 0.5 meter, sama dengan distance of the travel of the block. So US is then minus 1/2 times 500, okay, 500 Newton, 500 Newton per meter, the spring constant, multiply with 0.5 square minus 0. Okay, S1 equals to 0. So we have US, work done by spring, is negative 62.5 joule. Okay, minus 62.5 joule. Okay. Okay, so now it says when S equal to 0, position yang pertama, the block is at rest. So we know kinetic energy hanya ada apabila object is in motion. So apabila objek itu at rest, tidak bergerak pada awalnya, therefore initial kinetic energy T1 ialah kosong. Okay, because the block pada asalnya is at rest, tidak bergerak. So no motion, no kinetic energy. Okay, ini T1. What about T2? Okay, T2 ialah 1/2 mv2 square. V2 inilah yang kita nak cari sebenarnya. Okay, what we want to determine is the velocity of the block when S equals to 0.5, iaitu apabila pada position kedua, apakah velocity block tersebut. So ini yang kita nak cari. T2 is 1/2 mv square, V2 square. V2 square kita tak tahu. What we know is the mass. Mass is 10 kg. So we have T2 sama dengan 1/2 times 10, iaitu 5 V2 square. Okay, so sekarang kita dah ada initial kinetic energy, kita dah ada work done by force dan work done by spring, dan kita dah ada final kinetic energy T2. Now it's time to combine all these things into the principle of work and energy. Okay, T1 tambah total work done sama dengan T2, and now we substitute all the values. Okay, T1 sama dengan kosong. Total work done ini kita ada 200 minus 62.5. So plus 200 minus 62.5. T2 is 5 V2 square. So then we have V2 square dalam equation ini, which we can solve lah. So we can solve it. 200 minus 62.5 dapat berapa? Bahagikan dengan 5 dan you have to square root it to get V2 equals to 5.24 meter per second. Okay, so by using the principle of work and energy, we are able to solve this problem to calculate the velocity. Do you have any question? Any question? Tak ada soalan? Sekejap. Okay, do you have any question? No question, eh? Okay. So, kalau tak ada soalan, I will continue with the next problem. Okay. Well, maybe I will skip this problem. You can watch this in the videos that I have shared. Yang ni pun saya skip. I would like to go to the problem yang tak ada dalam video, which is this problem. Okay. So the rest of the problems yang ada dalam slides ini telah pun saya tunjukkan macam mana nak solve dia in the videos that I have shared in YouTube and also in Kalam. So you can watch the videos. Now I have two more problems yang tak ada dalam video. So I would like to show how to solve the problem which I have not covered in the video. Okay. So let's read this question. If the motor exerts a constant force of 300 Newton on the cable. So ada satu motor di atas ini pulling the box, okay, the crate ini, the motor is pulling the crate using a string, a cable. Okay, so motor ni memberikan force sebanyak 300 Newton to the cable and pulling the crate up. Okay, the crate weighs 20 kg, berat dia 20 kg when it travels 10 meter up the plane. Okay, so the crate is travelling 10 meter up, starting from rest. Okay, bermula daripada tidak bergerak dan motor ini memberikan constant force of 300 Newton, so the crate travel 10 meter going up. Ada friction, the coefficient of kinetic friction is 0.3. So what we want to determine is the speed ataupun velocity of the crate apabila dia sampai ke point S equals to 10 meter. Okay. So as usual, to start solving the problem, we need to draw the free body diagram. And in this case, we have a problem that is moving at an angle. So it will be easier for us to define the axis according to the plane kat sini lah. So when we have incline angle macam ni, so we can define x-axis following the angle. Okay, so the free body diagram, we have a weight pointing down. Okay, at contact point we have the normal force. We have the force pulling the crate by the motor, 300 Newton, and we have the friction force which is opposing the motion, pointing in the opposite direction of the travel. Okay, so which one of these forces are doing work? Anyone? Let me pick a name. Muhammad Hakimi. Force mana yang membuat kerja in this case? Muhammad Hakimi ada? Tak ada? Muhammad Razin ada?
Ada, sir.
Okey, Razin, daripada 4 force ini yang mana yang buat kerja?
F, sir.
F yang ini, F ke atas.
F ke atas.
Okey. Yang lain ada lagi tak?
Saya rasa F saja, sir.
F sahaja. Okey.
Ya.
Kenapa MG dengan NA tak buat kerja?
Sebab dia tak bergerak.
Okey.
Dia hanya bergerak F saja.
Okey. Okey. So kita akan tengok pada pergerakan kotak ini. So kotak ni bergerak dalam x-axis, betul? Dia bergerak x-axis ke naik ke atas. Alright? So that's why mg dengan na tidak buat kerja because there is no motion in y-axis. Tapi don't forget about the friction. Walaupun friction ini dia bertindak ke belakang, tapi dia masih lagi berada dalam aksis yang sama. Aksis yang sama dengan aksis yang mana kotak ni bergerak, okay, dalam x-axis. So selain daripada force F ini, friction force is also doing work. Okay, alright. So macam mana kita nak calculate friction force? FR ni sama dengan apa? Muhammad Akil ada tak? Muhammad Akil. Ada?
Ada sir, ada sir.
Okey, friction tu macam mana kita nak kira? FR friction ni sama dengan apa?
Sama dengan mu K darab normal force.
Yes. Okey, good. Sama dengan mu K darab normal force. Okey, so tadi kita dah bagi tahu force F ini buat kerja. Kita dah ada value dia. Force F sama dengan 300 Newton. So itu tak ada masalah. Cuma friction ni pun saya bagi tahu tadi, friction ni buat kerja juga. So bila friction buat kerja, kita perlu tahu what is the value of the friction force. Tadi Akil dah bagi tahu friction kita nak calculate sama dengan mu K 0.3 darab dengan NA, darab dengan normal force. Tapi normal force ini kita tak tahu lagi berapa value dia. So the first thing to do is to calculate the normal force. Okay, macam mana nak calculate normal force? Kita kena balik ke chapter 2. We have learned in chapter 2 that we can calculate the forces based on axis. So tadi kita dah define axis kita x positif ke atas pada angle 30 darjah dan y positif ke atas juga. So kita tahu bahawa box ini tidak bergerak dalam y axis. So we can write total force in y-axis sama dengan kosong. Okay, this is what we have learned in chapter 2, chapter 2. Okay, so from this free body diagram, kita boleh dapatkan forces yang bertindak dalam y-axis. Okay, dalam y-axis, can I call Marimutu? Marimutu ada?
Ada sir.
Okay. Apa force yang bertindak dalam y-axis?
The component of mg and na.
Okay, good. The component of mg. Bukan, you cannot, sorry, you cannot simply take mg because mg dia bukan directly in y-axis. Dia bertindak straight down. So you have to resolve mg into component. So mg ada komponen satu ke sini, ke bawah, mg cos 30 dan ada satu komponen ke in x-axis lah, which we are not interested in. Yang tu mg sin 30 degrees. So what we want is mg cos 30 degrees. So sekejap saya lukis in case ada some of you yang tak faham. So there is one component mg ke sini. Okay, there is another component pointing in this direction. Okay, so we have two component. So yang kita nak ialah komponen yang y-axis ini. Komponen x-axis ini kita tak nak pakai lagi. Okay, so komponen in y-axis is mg cos 30 degrees. Mana datang 30 degrees? Dia datang daripada sinilah. Since here is 30 degrees, down here is also 30 degrees. So mg cos 30 degrees, you get the component. So from here, we can get the value of NA. Okay, NA ialah mg cos 30. You can bring mg cos 30 to the right, you get NA sama dengan 169.91 Newton. Okay, so once we have the normal force, we can calculate the friction force. Friction is mu K times NA. So 0.3 times NA yang kita dah dapat tadi, we have FR is 50.9 Newton. Okay, 50.97 Newton. Okay. So, bila kita dah dapat friction force, kita boleh calculate work done by friction force lah. Tapi remember, friction force ini bertindak ke arah yang berlawanan, bertentangan daripada arah box ini bergerak. Therefore, friction ini bila kita calculate work done, kita kena jadikan dia negatif. Okay, so UFR ataupun work done by the friction is minus friction because friction ni pada arah yang bertentangan. Minus friction times delta S. Delta S ni berapa jauh the box has travel lah. Box has travel 10 meters. So delta S ni ialah 10 meters. So you get minus 50.97 times 10 is equal to minus 509.7 joule. Ini work done by friction. Okay. Next thing is to calculate the most easiest work done by the force exerted by the motor, 300 Newton. Okay, so UF sama dengan 300 darab dengan distance travel juga. So distance travel is 10 meter. So 300 times 10 meter you dapat 3000 joule. Ini work done by the force of the motor, UF. Okay, tadi UFR, work done by friction, negatif because friction bertindak pada arah yang bertentangan. Okay, what's left is the work done by weight. Sebab weight ada perubahan. Weight pada asalnya kotak ini berada di bawah, kemudian kotak tu naik ke atas. So definitely there will be change of height, akan ada perubahan tinggi. Box tu bergerak dari bawah naik ke atas. So there will be work done by weight. So UW is minus W times delta Y. Okay, how do we find delta Y? Okay, please pay attention. How do we find delta Y? So basically, if you look here, the center point of the box is the center of gravity. Saya tulis sebagai G di sini. Ini position number 1. Okay, position yang pertama. So apabila box dah bergerak 10 meters, G akan also travel 10 meter. Okay, G akan bergerak 10 meter juga. So ini yang kita nak cari, how much the center of gravity G has go up untuk kita dapatkan delta Y. So daripada sini point G yang pertama ke point G yang kedua di sini, kita boleh lukis satu triangle untuk kita visualize dia punya perubahan ketinggian tadi. So kalau kita lukis satu triangle, 30 degrees daripada sini ni akan bawa ke sini, samalah. Angle di sini akan jadi 30 degrees. Di atas ini, hypotenuse of the triangle is equal to the distance travel, 10 meter. Dekat mana delta Y? Delta Y is this one. Height from the first position ke second position. So this will be delta Y. Okay, if you look at the triangle, this side of the triangle is the delta Y. Okay, this is how you visualize how much the box has go up. Okay, so delta Y, once you have the hypotenuse 10 meter and also the angle 30 degrees, you can use 10 times sine of 30 degrees to get delta Y. Okay, this height, this side here is 10 sine 30 degrees. So you have delta Y is 5 meter. So basically the box has go up sebanyak 5 meter, sebanyak 5 meter. Okay, so once you have delta Y, dan remember delta Y ini naik ke atas. So dia akan jadi 5 meter positif, dia bukan negatif. Okay, once you have delta Y, kita boleh calculate the work done by the weight. Okay, so minus W is minus mg minus 20 times 9.81 times 5. Bukan minus 5 kan, times 5 because dia travel ke atas. So apabila sesuatu objek travel ke atas, work done by weight akan jadi negatif. Okay, kalau dia travel ke bawah, baru work done by weight jadi positif. So we have work done by weight is minus 981 joule. Okay, So all together inilah 3 work done yang telah yang ada dalam motion ini. Okay, dalam motion ini hanya 3 forces yang bertindak pada kotak ini yang menjalankan kerja, iaitu work done by friction, work done by weight dan juga work done by the force exerted by the motor lah, 300 Newton force. Okay. Now, let's look at the kinetic energy. Sebab remember, principle of work and energy mesti combine kinetic energy dan juga work done. Okay, so dia kata starting from rest. Kinetic energy ada 2 tadi, based on the equation yang kita dah belajar pada awal kelas tadi. Kita kena tahu apa T1 dan apa T2. T1 is the initial kinetic energy, T2 is the final kinetic energy. Kinetic energy yang akhir dan juga kinetic energy yang awal. So dia kata start from rest. Bila start from rest, terus kita tahu bahawa the initial kinetic energy is equal to 0. Okay, sebab starting from rest, initially no motion, tak ada motion, menunjukkan tiada kinetic energy. Okay, T2 is 1/2 mv square. Okay, so V ni yang kita nak cari. Kita tak tahu lagi. M is 20 kg. So we have 10 V2 square. T2 is 10 V2 square. So now once we have all this, we can combine into the principle of work and energy. T1 plus total of U, total work done sama dengan T2. Okay. So 0, T1 is 0, and then we have minus 509.7, minus 981, and plus 3000. Ini total work done lah, based on dia punya ni. That's why minus sign ini is very important. Kalau you tersilap, katakan you letak ini sebagai positif, then your final answer will be wrong. So it is very important to make sure you get the sign correct. Sama ada dia ialah positive sign ataupun negative sign. Okay. So you kena always check lah. So for example, work done by weight ini, kalau objek tu bergerak ke atas, mesti work done itu negatif. Kalau dia bergerak ke bawah, work done akan jadi positif. Dan juga work done by force pun kena tengok. Kalau force itu bertindak sama arah dengan motion, dia akan jadi positif. Kalau force itu bertindak opposite direction of the motion, dia akan jadi negatif. Okay, so once you have all this, kita boleh solve. Okay, kita tambah tolak-tolak dan tambahkan dia dengan 3000, bahagi dengan 10 dan square rootkan dia to get V2 equals to 12.29 meter per second. Okay. Alright, do you have any question?
Sir, when
Yes.
finding UW, right? I used a different way and I still got 981. I did negative 20 times m times g, then sine 30 times 10. And I still get negative 981. Can you also do it that way?
Sin 30 times 10 samalah dengan yang saya calculate delta y ni. Why do you do that?
So that way we don't have to calculate delta y lah. You can terus buat.
You mean you use the mg as a force?
Yes sir.
Okay, boleh juga. Kalau you use mg as a force, maksudnya you ambil component of this component kan?
Yes sir.
Boleh juga kalau macam tu. That way you consider mg ni sebagai force. So you tak buat delta minus weight times delta y, tapi you consider dia sebagai minus mg sebab dia ke bawah, times dengan delta S jugalah. Delta S which is 10 meter. Macam tu kan you buat?
Yes sir.
Yep. You can also do that. You will get the same answer. Okay, ada lagi soalan lain? Okay, if there's no more question, I would like to show one more example. Okay, this is a much interesting example to share with you. And then we will go into the next subtopic, which is a very small subtopic lah, iaitu power and efficiency. Okay, but this is the most important one. I want you to focus on this topic, principle of work and energy. Okay, when S is 0.6, okay, bila dia bagi tahu S is 0.6 bermaksud S yang pertama ni, initial position dia ialah S 0.6. Okay, ni initial position. The spring is unstretched. Okay, so ini pun satu information yang kita perlu understand lah. So dia kata pada initial position spring unstretched. So apa maksud dia nanti kita tengok. 10 kg block has a speed of 5 meter per second down the smooth plane. Determine the distance S when the block stops. Okay, ini slightly different from the previous example sebab tadi dia suruh kita calculate velocity. Sekarang ni dia suruh kita calculate distance, berapa jauh dia travel until the block stops. So soalan dia dah jadi lain sikit. Okay, let's look at what we need to do first, which is draw the free body diagram. So the block di sini ada weight mg ke bawah, ada normal force, okay, at contact point with the ground ada normal force, ada force by spring. Okay, tadi sometimes saya lukis force by spring, sometimes saya tak lukis, up to you lah, you boleh lukis ataupun you boleh tak lukis, tapi we know when there is a spring connected to an object, spring tu mesti akan melakukan kerja. So we can draw the force exerted by the spring. And also we have, saya lupa nak lukis kat sini because it's already there, the force applied ke bawah ni lah 100 Newton. Okay, so dia dah bagi tahu initially S equal to 0.6. Maksudnya ini position yang pertama, S 0.6. So kita nak tahu dia akan travel ke depan lagi sampailah box ni berhenti. Sampai box ni berhenti because it has exceed the length of spring. So bila dia akan berhenti, kalau you imagine the motion tu, because of 100 Newton force ni kita tarik sampailah maximum length of the spring yang dia boleh pergi. And then dia tak boleh pergi lagi, dia akan mula untuk patah balik naik atas because of the spring. Spring akan tarik dia semula ke atas. Okay, so kita nak tahu sampai berapa jauh dia akan berhenti, which is the maximum distance yang mana spring tu boleh pergi. Okay, I hope you understand dia punya soalan. So kita dah diberi S yang pertama, S yang initial is 0.6. So sekarang kita nak cari S yang kedua. Saya lukis sebagai S prime kat sini. S prime lah, ada satu tanda apostrofi dekat atas tu, showing that this is the S yang kita nak calculate, and in the end kita kena tambah dengan S yang asal ni untuk dapatkan total S yang total distance yang box ini telah travel lah. Okay, right, from all these forces, yang mana yang buat kerja? Let me ask siapa yang ada dalam ni Muhammad Faris ada? Muhammad Faris?
Yes sir.
Okay, Faris, boleh bagi tahu saya daripada force yang ada di sini, ada 4 force di sini, yang mana yang buat kerja?
Yang F.
Okay, yang F 100 Newton buat kerja. Lagi?
FS.
Spring, okay, spring buat kerja. Yang lagi?
Itu juga.
Ada perubahan tinggi tak?
Ada.
So kalau ada perubahan tinggi, weight akan buat kerja ke tak buat?
Oh, akan buat.
Okay, so ada weight. So basically ada tiga force yang akan buat kerja lah, sebab kotak ni akan bergerak dari atas, dia turun ke bawah sampai satu point. So bila ada perubahan tinggi daripada atas ke bawah ataupun daripada bawah ke atas, weight akan buat kerja. Okay, weight akan buat kerja. So please remember that. So daripada 4 force ini ada 3 yang akan buat kerja. Force F 100 Newton, force spring force dan juga weight. Okay, and then I forget to tell you that the question says the smooth plane. Maksud dia tak ada friction lah, tak ada friction yang terlibat. Okay, so let's calculate the, okay, dekat sini saya lukiskan kotak ni telah bergerak lah. So basically you can imagine kotak ni dia bergerak sampai ke sini. Okay, sampai ke bawah ni. Okay. So kita calculate yang paling mudah dulu, iaitu work done by 100 Newton force ini. Work done by 100 Newton force. Apa work done by 100 Newton force ni? Let me call Muhammad Syafiq, ada? Muhammad Syafiq, are you there? Tak ada? Chia Zhifeng ada?
Yes, sir.
Okay. Chia, so how do you calculate UF, work done by force? 100 Newton.
100 times 0.6.
100 times 0.6. Are you sure?
Yes.
Okay. Let's read the question again. It says when S 0.6. Maksud dia S 0.6 ini at this position. At this position, which means that 0.6 is the initial position. Let me write this down. Okay, this is 0.6. Okay, 0.6 is from here. This is 0 until here, 0.6. So this is position number 1. Dia start dekat sini. This is position number 1. And the box move to here, position number 2, which is down here. So now we are not talking about 0.6, tapi we are talking about this S here, which is unknown. That is why the question asks us to determine the distance S. So basically, kita belum tahu lagi what is the distance yang box to travel. So to calculate UF, is basically 100 times S prime ini. 100 times S prime. This is the distance from position 1 to position 2, which is S prime. So you don't know what is S prime yet. This is what we are going to calculate. Do you understand, Chia?
Yes, sir.
Okay. Alright, so we'll continue. So UF is then UF is then 100 times S prime lah. Itu saja yang kita boleh calculate because we don't know what is the value of S prime yet. Okay, now we move on to work done by weight. So ada weight, ada change of height daripada position 1 ke position 2. So you can calculate work done by weight is minus W times delta Y. So here we need to know what is delta Y. So again, I like to draw the triangle. So for you to understand better, okay, so we have a triangle here. Delta Y is basically this side of the triangle lah, yang tinggi ni. This will be delta Y. Okay, you have the hypotenuse of the triangle is equal to S prime. Okay, I forgot to put the apostrophe here. This should be S prime, and this is delta Y, yang tegak ni, yang vertical. So this is delta Y. Okay. This which is basically equal to S prime times 30 degrees. S prime times 30 S prime times sine of 30 degrees. So when you calculate sine 30 degrees, you will get 0.5. Okay, sine 30 degrees is 0.5. So delta Y is then equal to 0.5 S prime. Okay, 0.5 S prime. So then you can input this in the equation to get minus 10, ni mg lah, minus 10 times 9.81 times minus 0.5 S prime. Kenapa minus? Because now it is moving downwards. Daripada atas turun ke bawah. So delta Y itu negatif. Yang soalan tadi moving up, daripada bawah naik atas. Bila bawah naik atas, delta Y positif. So the work done will be negative. Now delta Y negative, so work done will be positive. Okay, so negative here and negative sign here will cancel out each other and will become a positive lah. Delta work done by weight will be positive. So you dapat UW 49.05 S prime. Okay, so kita ada semua work done nanti dalam dalam S prime lah, dalam sebutan S prime. You have S prime in the in all the work done. Later baru kita dapat cari what is the value of S prime. Okay, so kita dah calculate work done by force, work done by weight. Now let's move on to work done by spring. Okay, minus half times K. K is given 200 Newton per meter. This is the spring coefficient. S2 is unknown. S1, it says here, pada awal, pada position pertama, spring is unstretched. So therefore we know S1 equals to 0 lah. So there is no S1 because pada awal spring tu tidak stretch. Jadi dia pada original length. So there is no compression or stretch of the spring. Jadi S1 sama dengan kosong. Remember S1 is the sama ada compression ataupun elongation of the spring. So if the spring is at original length, jadi S1 sama dengan kosong. Okay, S2 is then sama dengan S prime lah, because daripada sini original length of the spring dan dia turun ke position number 2 here. So how long the spring has elongated, berapa panjang spring tu dah memanjang, ialah sejauh S prime. Pemanjangan dia sama dengan S prime ini. So we have S2 here is equal to S prime square. Okay, so minus 1/2 times 200 times S prime square. So you will get US is negative 100 S prime square. Okay, this is what we have. Alright, what about T1? Let me ask Goh Pei, are you there?
Yes, sir.
Okay, what is the value of T1? Is it equal to 0?
I think it's equal to 5 meter per second.
Okay, good. Slightly incorrect, tapi almost there. Okay, if you look at the previous example, semua T1 sama dengan kosong because it says initially at rest. Tapi not in this question. It says here, pada position pertama, S equal to 0.6 here, at this position, the block has a speed of 5 meter per second. Maksud dia, blok tu initially sedang bergerak. Dia bukan daripada duduk diam. Dia sedang bergerak 5 meter per second. So T1 is not equal to 0, but it is equal to 1/2 mv1 square. V1 ini is 5 meter per second. So T1 is 1/2 times 10, the mass times 5 square. So you have 125 joule for T1. Okay, what about T2? Let me ask Goh Pei again. Goh, what is T2?
T2.
Look at this. Determine distance when the block stops.
Stop. 0.
Yes. Okay. So I mentioned about the spring. The spring, the box will travel until the maximum length the spring can go, and then it will stop before it go back ke atas lah. So when the block stop itu ialah position yang kedua kita. So because it says the block stops, now we know T2 sama dengan kosong. Sekarang ni terbalik. This problem is the opposite of the previous problem yang kita dah calculate. So please make sure that you are able to understand the question. Okay, sekarang ni question ni dia bagi tahu pada awal block tu ada velocity, ada speed, and then in the end the block stops. So bila block stop, in the end T2 sama dengan kosong. Okay, now what do? We apply the principle of work and energy again lah. Okay, T1 tambah total work done sama dengan T2. So T1 is 125, you bring here. Total work done ni bawa semua yang ada S prime ni. So you have 100 S prime plus 49.05 S prime minus 100 S prime square sama dengan T2 is 0. Okay. Sekarang you boleh susun. Bawa ni yang ada square ni ke depan. So jadi minus 100 S prime square plus, yang ni kita tambahkan terus. 149.05 S prime plus 125 equals to 0. So sekarang you nampak satu equation yang ada S square, S and value lah. Okay. So macam mana nak solve this? You can use your calculator. Okay, I have an example here. Saya tunjukkan cara. You use the mode, click mode and change to equation. Okay, click number 1, equation, and ada sini unknowns tapi you pilih ke kanan. Choose degree. Now choose 2 degree. Why you choose 2 degree? Because because dia punya S prime ni square. So dia ini maksud dia second degree. Let me play back the video again. Sekejap, macam mana saya nak play back? Okay, let me go to the... Okay, here you choose degree. Okay, degree choose 2. Okay, now dia tanya A. A is the first one yang ada square. So you key in minus 100 for A. Okay, you key in minus 100 for A. Alright. Sekarang you tekan sama dengan, and then it will ask for B. B is the second one, 149.05. Positif yang ni. So you key in positive 149.05, tekan sama dengan, and C is the last one, 125. Okay. Now when you press equal, dia akan keluar dua jawapan, X1 and X2. So you are going to exclude the negative answer. Okay, X1 ni negative, this is not correct. What you want is the positive answer because mana ada distance yang negative, distance must be positive. So yang negative tu is the wrong answer lah. Okay, so we have S prime is 2.089 meter and the question tanya tentang S, the total length. So we have to tambah dengan 0.6 length asal. So in the end you get S is 2.689 meter. Okay. Alright. Do you have any question? Ada apa-apa soalan tentang soalan ini? Okay. So if there's no question, I will continue to the next subtopic. I will stop sharing my screen first. If you do not understand anything, just go back and watch the video again lah. Okay, watch the video again. I have shown many example in the lecture video, so please watch and try to do the example by yourself. Okay, it's very important. The topic principle of work and energy, which is the main topic for this chapter lah. The main topic for chapter 3 is the principle of work and energy tadi. Okay, this is a very small subtopic, power and efficiency, just for you to know lah. Okay, so kita akan in this lesson we will understand the concept of power, how to calculate power and understand about efficiency. Okay, so power generated by a machine is the work done within the time interval. Okay, tadi kita dah belajar work done dan juga kinetic energy. Now from the work done yang kita calculate tu, kita boleh calculate the power generated by the machine, the motor for example, within a time interval dt. Okay, so P is equal to du divided by dt. Okay, this is the definition. So how to calculate? We know that du is F times dr. Okay, du ni work done lah. force times displacement. R is the displacement. Okay, now F dr ni, du over dt, P is du over dt. So we have F dr over dt sama dengan, kita boleh keluarkan F itu. So kita tinggal F times dr over dt. Do you know what is dr over dt? Ataupun ds over dt? Anyone? Kita dah belajar awal dulu. First kali kita belajar dalam dynamics is ds over dt. What is ds over dt?
Velocity.
Velocity.
Exactly. Thank you, Marimutu. ds over dt is the velocity. So how to calculate the power is basically to multiply the force with the velocity. Okay, that is it. Macam mana nak calculate power? Force kali velocity. Macam mana nak calculate work done? Force kali distance. Okay, so you have to understand the concept. Force kali distance is the work done. Force kali velocity is the power. Okay, power is force times velocity. Unit of power is watt. Okay, kalau work done tadi unit dia ialah joule. Now power punya unit ialah watt. Okay, what about efficiency? Efficiency is defined as the ratio of output produced by the machine divided by input power. Okay, so efficiency will never exceed 1 sebab output mesti there must be loss to surroundings. So output tak akan sama dengan input. So most probably we will get the value like 0.7, 0.8 and so on. Okay, the higher the number, the better the efficiency of a machine. Okay, now let's look at a few example. A simple example. The contact surface between 20 kg block is smooth. Jadi no friction lah. Dia bagi tahu surface is smooth. Determine the power force F when T equals to 4 seconds. Initially the block is at rest. Okay. So tadi kita dah tahu macam mana nak calculate power is the force times velocity. So what we need to know is what is the velocity of the block when T is 4 seconds. Okay. So we draw the free body diagram. Ada weight pointing down, ada normal force, but these two is not doing any work because the distance travel is to the right. This component is also not doing any work. Yang buat kerja hanya this component, 30 times 4 over 5. Work done in x-axis only. So now kita balik kepada chapter 2 sedikit untuk dapatkan what is the velocity. So in chapter 2, we learn F equals to ma in x-axis. So in x-axis, if you look at in x-axis, kita ada 30 times 4 over 5 component of force sama dengan ma, 20, m is the 20 kg, 20 times ax. So we have ax is 1.2 meter per second square. Okay, and we know that this force is constant. So we can use the constant acceleration punya equation to get the velocity. Okay. We know V naught equals to 0. Why? Because the block is initially at rest. The block is at rest, jadi V naught is the V initial velocity. So initial velocity 0 lah. So we have V equals to AX times T. AX kita dah ada. Time T is given in the question, 4 second. So kita dapat velocity is 4.8 meter per second. Therefore, the power is force times velocity. But remember, not 30 Newton. The only force yang buat kerja, which is the component. Component ini tak buat kerja because the box does not move up and down. The box only move to the right. Jadi only this component of force is doing work. Jadi you have to take Fx only. 30 times 4 over 5 multiply with the velocity 4.8 meter per second. You will get the power 115.2 watt. Okay. Any question? All right. Let's look at another example. 50 kg load A. This is 50 kg of weight. is hoisted by motor so that the load has constant velocity, 1.5 meter per second. So this thing, this box is traveling up with 1.5 meter per second. Determine the power input to the motor, which operates at efficiency of 0.8. Okay, now efficiency is given. So we can draw the free body diagram, mg, and tension. Okay, there's a cable pulling the weight, the box. So there must be tension in the cable. So we go back to chapter 2 to get the tension here. So we know that V is constant. It says constant velocity. So when V is constant, AY is equal to 0 lah. Constant velocity means there is no acceleration in y-axis. Okay, so when there is no acceleration, we can then calculate the tension. T minus 50 times 9.81 sama dengan 0. Okay, this on the right hand side is 0. So T is 490.5 Newton. Okay. The power output is the tension times the velocity. Okay, tension is the force, okay, times the velocity, 490.5 times the velocity 1.5, you get 735.8 watt. Okay, but the efficiency is given, so this is not the actual power by the motor. Actual power by the motor mesti lebih tinggi because there is efficiency of 0.8. So efficiency 0.8 is P out divided by P in, P input. This is P output. Okay, so we get P input is 919.7 watt. Okay, 919.7 watt. All right. So that's all that I would like to cover regarding power and efficiency. This is just a very small subtopic, just for you to know that power is force times velocity, and efficiency is the power output divided by power input. Okay, so we have learned about power and efficiency of a machine or engine, and we have solved several problems related to power and efficiency. All right. So again, I would like to remind you to go back and study chapter 1, chapter 2, and also chapter 4. Chapter 3. What we are covering today for the quiz next week. So I will see you face to face on Monday, 10 AM. Dewan Kuliah 300 FTKMA. Okay, we will have the last subtopic of chapter 3 first. We learn about the subtopic first, which is the conservation of energy, and then we will do the quiz, 4 quizzes in 1 hour, 15 minutes for every quiz. Okay, quiz 1, quiz 2, quiz 3, quiz 4. Please study because it will contribute 24% of your marks. So it is very important, very large portion of marks. So I hope you can do that and I hope you can get a good results lah. Okay. All right. So do you have any question before we end the class for today?
Sir, quiz for work and kinetic kan?
Macam mana?
Untuk quiz 4, dia punya ni work and kinetic energy. Ke yang kita akan belajar pada hari tersebut?
Oh tak, bukan yang kita dah belajar sehingga sekarang.
Okay.
Yang kita dah, yang apa example yang saya tunjuk lebih kurang macam tu for the quiz. Bukan yang kita akan belajar nanti.
Okay.
Alright. Ada lagi soalan lain? Okay, so if there's no more question, thank you for coming to the class today. I will share the recorded video recording for today, and I will see you again face to face on Monday. Assalamualaikum and have a good day.
Salam, thank you.
Thank you, sir.